Hello everyone, welcome to our lecture number 15, and in this lecture we will discuss regarding your electric flux and area vector. So let's start the topic. Area vector and electric flux. So first, all of you listen. What is the meaning of area vector? So from the beginning we all know that area is a scalar quantity. Yes. Acha area vector पढ़िया combine नहीं. That is the concept. Why we will discuss area vector? Listen. So electric flux means what? Remember, electric flux gives a sense of electrical energy passing through an area. Electrical energy passing through an area. How much amount of electrical energy that is passed through an area, that can be determined by electric flux. Yes. And also remember, electric flux, your electric flux, it involves two things. One is your electric field, and up to lecture number 14 we have discussed in detail about your electric field. That part I already covered. And electric flux also involve area vector. ए दुईटा क्वांटिटी इलेक्ट्रिक फ्लक्स कंटेन करे तो डिटेल से स्टडी करवा. सो फर्स्ट आम तो पढ़ी सारी वी हैव ऑलरेडी डिस्कस्ड रिगार्डिंग योर इलेक्ट्रिक फील्ड. सो लेट्स स्टार्ट आवर टॉपिक एरिया वेक्टर. Most awaited topic of our first chapter. Yes, remember the explanation here about area vector. The explanation here is for understanding purpose. The explanation here is for understanding purpose only, since not all areas are vector. Remember, only differential element have area vectors defined for them. चलो आम गोटे सिंपल एग्जांपल बुझा. यस, सपोज मु कहबी दिस इज द फ्लो ऑफ वाटर. दिस इज योर फ्लो ऑफ वाटर. थिंक इट. एंड दिस इज अनदर केस. आम ए भर गोटे रिंग रखा. रिंग, इफ द रिंग इज प्लेस्ड हॉरिजॉन्टली विथ रेस्पेक्ट टू सरफेस ऑफ वाटर, and in second case ring is placed, that same ring is placed vertically with respect to surface of water. बुझेला बस. सो फर्स्ट केस रे रिंग रहा आमर हॉरिजॉन्टली, रिंग प्लेस्ड हॉरिजॉन्टली. सो रिंग प्लेस्ड हॉरिजॉन्टली, and in second case a ring is placed vertically. सो जदि मुझे पचारि ये थ्रो द एरिया ऑफ द रिंग केते अमाउंट वाटर क्रॉस करी गला. सो इन फास्ट केस मन रखी था, फास्ट केस रे आमर आंसर आसीबो नील, कारण हॉरिजॉन्टली अच्छी टैंजेंशियली सरफेस अच्छे से टैंजेंशियली कौन अटैच हो पड़ेगा आमर फ्लो ऑफ वाटर. बट इन सेकेंड केस थ्रो द एरिया कौन मैक्सिमम अमाउंट ऑफ वाटर क्रॉस करुच्ची. सो फास्ट केस ऑफ सेकेंड केस देखो एरिया रिमेन सेम, but the direction of orientation that matters. How much amount of water is crossing through an area. Yes, so in certain cases or in some cases we have to treat the area as a vector quantity. Clear? Okay. So area जब vector quantity है ताल तार डायरेक्शन केमती आम पाइबा यस इफ एरिया इज ए वेक्टर क्वांटिटी हाउ कैन यू डिटरमाइन इट्स डायरेक्शन मैग्नीट्यूड सेम एज प्रीवियस प्रोसीजर सपोज मुझे पचारि तुमको सपोज दिस इज योर एरिया consider that this is an area consider that this is an area ठीक अच्छे अच्छा ये केस रे एटा 3D फिगर देखो दिस इज द एरिया ओके तार लेंथ केते लेंथ इज L एंड ब्रेथ इज B सो एरिया वेक्टर केते हबो सपोज मु पचारिबी दिस इज योर x axis y axis and z axis I have drawn like this yes this is x axis y axis and z axis and always remember direction of area vector means out drawn normal okay that is perpendicular to the surface area yes so perpendicular कहबा माने एटा ही perpendicular हे परिबो perpendicular direction yes and below भी हे परिबो किछ असुविधा नहीं बस so this can be written as a cap or this is your a cap so मुझे पचारिबे एठी area vector a vector is how much a vector answer so area magnitude is L into B and direction upward direction आम नहीं positive y axis that is j cap and or आम एमपी लिख परिबा a vector is equals to here L into B minus j cap both are correct for this case both are correct for this case exactly यदि पचारि तुमको ये क्वेश्चन दिया है if this is your area this is suppose the figure is given like this and in this case the area is placed as per the figure clear and this is the length and this is the breadth area vector कौन हम normal draw करिया to the surface normal to the surface back side भी परिबो obviously ही परिबो द को डायरेक्शन से मैच कला x axis so here area vector केते हबो area vector a vector is equals to L into B I cap or area vector is equals to L into B minus I cap both are correct I hope it is clear to all of you भल से बुझ पाइल बर्तमान सिंपल आम कम्प्लेक्स को जीवा सिंपल एग्जांपल आम कम्प्लेक्स को मूव करवा सो किछटा पार्ट आम कौन करुचे एरिया को वेक्टर को ट्रीट करवा वेक्टर द्वारा ट्रीट करवा यस देखिए धीरे धीरे आम तार सब डिटेल्स पढ़ा बर्तमान व्यस्त होनी नेक्स्ट इज रिमेम्बर व्हेन एरिया एलिमेंट इज ए पार्ट ऑफ क्लोज्ड सरफेस आम सेकेंड पेज को जीवा सेकेंड पेज नाउ सी व्हेन बहुत इंपोर्टेंट एटा व्हेन एरिया एलिमेंट is a part of closed surface is a part of closed surface सही टाइम में कौन करिया पड़िबो रिमेंबर दिस पॉइंट प्रॉपर्ली देन आउटवर्ड सेंस determines the direction of the area vector बहुत सारा न्यूमेरिकल पॉइंट यूज होगा व्हेन एरिया एलिमेंट इज ए पार्ट ऑफ क्लोज्ड सरफेस देन आउटवर्ड सेंस डिटरमाइंस द डायरेक्शन ऑफ एरिया वेक्टर अच्छा ठीक अच्छे सपोज दिस इज ए स्फीयर लेट अस कंसीडर दिस इज ए स्फीयर ओके एंड आम तार गोटे डिफरेन्शियल एरिया नवा छोट एरिया बर्तमान मुझे कनसीडर कली स्मॉल एरिया आउट ऑफ द टोटाल ताले एरिया मैग्नीट्यूड केते इस डिफरेन्शियल एरिया छोट एरिया मैग्नीट्यूड डी ए ताले तार डायरेक्शन कौन हम आउटड्रन नॉर्मल सो आउटड्रन नॉर्मल बिकॉज ए ग्रीन कलर एरियाटा होल सरफेस एरिया गोटे छोट पार्टे ना सो व्हेन एरिया एलिमेंट इज ए पार्ट ऑफ क्लोज्ड सरफेस एटा गोटे क्लोज्ड सरफेस देन आउटवर्ड सेंस डिटरमाइंस द एरिया वेक्टर दिस इज डी ए वेक्टर क्लियर वेरी गुड सपोज मुझे पचारि गोटे क्यूब ड्रॉन करी सपोज दिस इज मो सेकेंड केस ना गोटे क्यूबटे ड्र करवा बस देखो सिंपल क्वेश्चन में बहुत ही जिनस इजिली बुझीपर ठीक अच्छे दिस इज आवर क्यूब एंड एट आम नेमिंग देला मुझे पचारि एरिया वेक्टर फाइंड कर बहुत सारा न्यूमेरिकल भी मुझे करी दिस पार्ट पार्ट कर वीडियो तैयारी करदेवा ओके सो ए बी सी डी अनदर वन इज ई एफ जी h. ठीक अच्छे. And let us think, this is your y direction, x direction, and this one is z direction. তাহলে পচারা কোশ্চিন এ ভেক্টর অফ BCGH. BCGH surface জানিপারছ, BCGH, that means this one. এর সবু সাইড দিয়েছি কেতে এ, each side is a. তাহলে এর এরিয়া ভেক্টর ভ্যালু কেতে হবে, ম্যাগনিটিউড ইজ a স্কোয়ার. দেন ইট ইজ এ পার্ট অফ BCGH ইজ এ পার্ট অফ ক্লোজ সারফেস. তো আউটওয়ার্ড সেন্সটাকে আমি নেবা এরিয়া ভেক্টর ডাইরেকশন. এটা কেউ ডাইরেকশন তো ম্যাচ করলা, পজিটিভ এক্স অ্যাক্সিস ও প্লস আই ক্যাপ. ভেরি সিম্পল. এরিয়া ভেক্টর অফ EFGH সারফেস, EFGH কেউ সারফেস আসলে দেখো EFGH, দিস ওয়ান. তাহলে আউটওয়ার্ড সেন্স মানে বাস এটা কেউ ডাইরেকশন হল নেগেটিভ ওয়াই অ্যাক্সিস. সো এরিয়া ম্যাগনিটিউড ইজ এ স্কোয়ার, দিস ইজ মাইনস জে ক্যাপ. এগেন মু যদি পচারিব এরিয়া ভেক্টর অফ ADFE, ADFE সারফেস জানি হচ্ছে ADFE, দিস ওয়ান ADFE. হোয়াইট কলর ମୁଁ সেট କରିଦେଲି বাস. ইট ইজ অলসো এ পার্ট অফ ক্লোজ সারফেস. সো আউটওয়ার্ড সেন্স କରିଦେବା এরিয়া ভেক্টর নেগেটিভ এক্স অ্যাক্সিস. সো a স্কোয়ার ইন্টু মাইনস আই ক্যাপ অর মাইনস a স্কোয়ার আই ক্যাপ. ক্লিयर. सपोज ମୁଁ नेक्स्ट क्वेश्चन पचारि तुमको. सपोज क्वेश्चन दिगला, देख नेक्स्ट क्वेश्चन कौन देला, दिस इज ए डिस्क, सॉरी yes, and given that these are the three axes. It is not a closed surface. Okay, remember that point. अच्छा, यार radius के देला given, radius is r. ताले पचारला find area vector for following, और पचारला find area vector. Find area vector. This is the question. आंसर आम कौन लिखा कह, आंसर कही तो पार, जस्ट यू कैन लिसन. आंसर इज तार एरिया के एरिया इज पाई आर स्क्वायर. यस, डायरेक्शन ऑफ एरिया वेक्टर, दैट इज मोस्ट इंपोर्टेंट. इन रेड कलर वी कैन मार्क इट. सो दिस इज योर एरिया वेक्टर एंड ऊपर को हो पार, व्यस्त ना. सो पॉजिटिव वाई एक्सिस एंड नेगेटिव वाई एक्सिस बोथ आर करेक्ट. एरिया मैग्नीट्यूड इज पाई आर स्क्वायर, दैट इज ट्रू. सो एरिया वेक्टर ए वेक्टर इज इक्वल टू पाई आर स्क्वायर प्लस जे कैप, और एरिया वेक्टर इज इक्वल्स टू पाई आर स्क्वायर माइनस जे कैप. बोथ आर करेक्ट. क्लियर, बोथ आर करेक्ट. वेरी गुड. सो नाउ आम आउ गोटे क्वेश्चन करिया बर्तमान. लेट्स थिंक अबाउट अनदर क्वेश्चन. गुड क्वेश्चन आम करिया. क्वेश्चन कौन देला देख, स्क्रीनशॉट नहीं गलो. यस, come to next question. Given that these are three axes, x, y and z, and in this case it is mentioned this is the figure, and it is mentioned 2 meter and this length is 5 meter suppose, and it is mentioned this angle is 30 degree. Yes, so question is, your question is find area vector. Find area vector. How can we find this one? Now see this thing properly. So ये question आम सॉल्व करिया again आम diagram देखिबा. This is the question, and here again you have to draw the diagram. Yes, and next come to the solution part. The solution part is very interesting. Okay, let this is your L and this is your B. Yes, acha, length is coinciding along y axis, so we can write L vector is how much? L vector is, we can say here as per the figure, L vector is equals to 2 j cap meter or 2 meter j cap. You may write 2 meter j cap. सिंपली आम लिखा के 2j कैप खाली लिखुँ मु सॉल्यूशन करिया नन कन्फ्यूजन हम 2j कैप ऑल आर इन एसआई यूनिट डोंट वरी अबाउट दैट थिंग द यूनिट ऑफ एरिया विल बी मीटर स्क्वायर यस अच्छा नेक्स्ट दिस b part can be resolved into two components b vector can be resolved into two components what are they so one component in red color I am going to mark this will be one component and this will be another component and remember this is not obtuse angle this is your 90 degree angle between x axis and z axis is 90 degree so angle attaching component is cos component so along x axis the component will be 5 cos 30 degree and along z axis the component will be 5 sin 30 degree this will be 5 sin 30 degree clear so as per the figure we can write b vector is equals to 5 cos 30 I cap plus 5 sin 30 degree k cap clear so b vector can be written cos 30 means root 3 by 2 so it will be 5 root 3 by 2 I cap plus sin 30 is 1 by 2 so 5 by 2 k cap this one is your b vector and here is your this is L vector so what is the value of area vector so area vector will be L vector cross b vector L vector cross b vector so it will be L vector value is 2j cap and cross b vector value is 5 root 3 by 2 I cap plus 5 by 2 k cap yes then distributive property we have to apply to 2 into 5 root 3 by 2 j cap cross I cap then plus 2 into 5 by 2 j cap cross k cap अच्छा क्रॉस प्रोडक्ट को केमती आम सॉल्व करिया तो ट्रिक कौन सिंपली यू मेंशन I cap j cap k cap in your rough copy then again you write I cap j cap k cap so towards positive direction को positive x direction गले positive and along negative x direction the answer will be in negative केमती आम क्रॉस प्रोडक्ट चिन्हवा just recall those concept of first year okay 11th class concept suppose मु कहबी I cross j then तापर जो ऑर्डरटा आसीबो k cap लिखा है so दा कुआडे अप्रोच कलो along positive direction so this will be plus k cap if I will say j cap cross I cap so the next term will be the answer minus k cap like this so j cross I is minus k cap so this will be after solving we get 5 root 3 into minus k cap plus then 5 into j cross k so plus I cap so it will be plus I cap clear this is your answer so final answer is 5 I cap minus 5 root 3 k cap this is our area vector clear so this was meter square you may write the unit also actually you may write the unit this much meter square yes so as per the given question this is your answer I hope regarding your area vector each and every concept is clear to all of you yes so if you will face any difficulty regarding your area vector then you may share your opinion in comment box okay so next come to electric flux yes that part is very important electric flux so what is that so remember electric flux is denoted by phi that is phi e or you may represent phi so electric flux is a measure of number of electric field lines passing perpendicular through a surface passing perpendicular through a surface. Don't think that the number is called your electric flux. Okay, many of you are thinking that the number of field lines crossing through an area perpendicularly. That is not true. It is a measure of number of electric field lines passing perpendicular through a surface. Yes, that is called your electric flux. Yes, suppose for example, if I will say this is suppose the area. Yes, this is suppose the area, same area we are thinking about, same area. Okay, and in first case suppose these are the field lines, passing perpendicular through the area, and in second case number of field lines that passes through or crosses through an area, that is the number is more, suppose. Yes, this is your electric field vector, this is your electric field vector. So in this case suppose flux phi 1 and electric flux is phi 2. So in which case flux is more? So remember, in second case the flux is more, phi 2 is greater than phi 1. So I have already written it is a measure of number of field lines. So in the case in which number of field lines that crosses through an area perpendicularly, that is more, we can treat that surface is having maximum number of flux. Okay, so it is a measure of number of electric field lines passing normally through given surface area. Yes, so how can we determine the value of electric flux? Okay, how can we determine the value of electric flux? That is one question. So listen, I am going to draw a diagram actually to what is the working formula to calculate the electric flux. This is suppose the surface, this is the surface, and in this surface the area vector is this one, this is the area vector, suppose area vector A vector. And what is the direction of electric field? Electric field is acting along as per green color direction. This is the direction of electric field, this is the direction of electric field. Yes, so first you have to calculate and the angle between area vector and electric field vector is theta. So we can split the electric field into two components, obviously. So one component is this one, another one is along area vector, and along the area vector one component is there, and perpendicular to area vector another component is there. So along the area vector the component is E cos theta and other component will be E sin theta. Yes, also you remember you can split the area vector into two components. In this diagram also you see one more thing, that is also important. In first diagram में कौन कले? In first diagram we have split electric field vector into two components. In second diagram what we have to do? We have to split area vector into its two components. What are those components? One is your this component. Yes, this red color line shows one component of area vector, and other one is this one. Yes, so angular attaching component is cos component, this will be A cos theta, another one will be A sin theta. So what is the working formula? Remember, when component of area, or you must think area and electric field both are in same direction, you have to take their product. Clear? That means my summation is you can treat phi is equals to, you may write A into, for first case A into E cos theta, or in case of second diagram you can say phi is equals to A cos theta into E. So for both cases you will get the same result, phi is equals to EA cos theta, or EA cos theta can be written as E vector dot A vector. Bas, this is our working formula. What is the angle theta? Theta is the angle between area vector and electric field vector. Yes, this part is very important. So this is the working formula for calculation of electric flux. Okay. Also you remember regarding electric flux, that working formula in note point you may write, in note point we can say note point you can say working formula is first point about electric flux. Phi E is equals to E vector dot A vector, that is equals to EA cos theta. Second point, it is a scalar quantity. Electric flux is a scalar quantity. Always remember, it is a scalar quantity. And third thing, its unit. What will be the unit? Electric field intensity into area. Electric field intensity unit is Newton per coulomb. Area unit is meter square. Yes. So its SI unit is Newton meter square per coulomb. And what will be the dimension? Dimension of electric flux, that is equals to dimension of electric field into dimension of area. Dimension of electric field into dimension of area. Electric field can be written as F by Q. So dimension of F, dimension of Q into dimension of area. F dimension is 1 1 minus 2, m1 l1 t minus 2, and your charge dimension is a1 t1, and area dimension is l2. So the final answer will be m1 l to the power 3, then t minus 2 minus 1 is minus 3, and a minus 1. 1 3 minus 3 minus 1 is the dimension of electric flux. Okay. Next we will discuss 4 cases regarding your 4 cases based upon your electric flux. Okay. So case number 1. Case number 1. What is our case number 1? Suppose this is our area. This is the area. And here area vector is this one. This is your area vector, A vector. And what is the direction of electric field? This is suppose the direction of electric field. As per this second color, electric field vector. Okay, brownish color. Yes. So in this case, what is the value of flux, electric flux? So for first case, the electric flux value phi is equals to, it will be EA. Electric field and area vector both are parallel to each other. So EA cos theta, that is cos 0 degree, and it is your observer. Observer is observing from this side. Yes, observer. So it will be phi is equals to cos 0 is 1 E into A. So this is positive. This is positive. So for the observer, the electric field lines are in outward direction. So we can say outward flux taken as positive. So thus we can write outward flux taken as positive. Outward flux is taken as positive. Is taken as positive. Yes, this is your case number 1. So next come to case number 2. Case number 2. Case number 2 is what? Case number 2 is, suppose this is that area. Case number 2, this is the area, and your area vector is A vector, and the electric field vector is as shown in figure in green color, and observer is observing this thing from this side. So here area vector and electric field vector both are anti-parallel to each other. So flux phi is equals to EA cos 180 degree. Cos 180 is minus 1. So this will be minus EA. So always remember, outward flux is taken as positive. In this case, this is inward flux as per the observer. So inward flux is taken as negative. Inward flux is taken as negative. Yes, this is your case number 2. Okay. Yes. So next come to your case number 3. So in case number 3, we can say case number 3. What is the diagram? The diagram is just shown in figure. This is suppose the area, and this is your area vector. This A vector is our area vector. And in case of you can say these white color lines are electric field lines. These are electric field lines, E vector. So here the angle between E vector and A vector is 90 degree. So your flux phi is equals to E into A cos 90. Cos 90 is 0, answer will be 0. Clear? So always remember here electric field lines are along the plane. Electric field lines are along the plane. So when electric field lines are along the plane, then electric flux is 0. So next come to our case number 4. Case number 4. Okay. So suppose this is your unknown figure. This is unknown figure and it is your area vector, and it is given that the red color line shows the electric field. Red color line shows the electric field vector. Red color line shows the electric field vector. And with respect to plane, surface of the plane, okay, angle between E vector and with respect to horizontal, electric field makes an angle phi. So what is the electric flux? So condition is if electric field makes an angle phi, with plane surface. So in this case we have to think about the angle between what? Angle between two things, area vector and electric field vector. So the angle is 90 minus phi. The angle will be 90 minus phi. So electric flux is equals to, you may write theta actually. Okay, this is phi. So phi E is equal to EA into cos angle between electric field and area vector 90 minus phi. And cos 90 minus theta is sin theta. So 90 minus phi, so you can write EA sin phi. So as per the case, you have to find the answer. Okay. So next, one more thing is there. What is that? Now see. Important point. If E vector is equal to, let E vector equal to EXI cap plus EYJ cap plus EZK cap, and A vector is equals to AXI cap plus AYJ cap plus AZK cap. So what is the value of electric flux? So phi is equals to answer E vector dot A vector. So simply you have to remember this thing, EX into AX plus EY into AY plus EZ into AZ. This will be the answer. So the answer will be EXAX plus EYBY, EYAY plus EZAZ. This is the answer. Clear? Okay. So let's solve one question. The question is, question tomu dela, a rectangular surface of side, of side 10 centimeter and 15 centimeter is placed inside a uniform electric field of strength 25 Newton per Coulomb, such that normal to the surface makes an angle of 60 degree, with the direction of electric field. This part is important, with the direction of electric field. Okay, so in this situation find the flux of electric field. So find the flux of electric field through the rectangular surface. So read the question properly. So before proceed to solution, read this question properly. What are the given data? First you have to mark that data. Yes, let's mark that data. So rectangular surface of side 10 cm and 15 cm, this is one data. A strength of electric field is 25 Newton per Coulomb, and electric field is normal to the, so that normal to the surface means area vector, makes an angle 60 degree with electric field. So angle between area vector and electric field is 60 degree. Okay, so as per the figure, actually as per the question, you can draw the figure like this. This is your uniform electric field, this one is uniform electric field, and if you will take the side view, the rectangular surface behaves like a line format. Okay, rectangular surface we can draw it in case of line format as per side view. Yes, so this is your surface, a rectangular surface. This is the surface actually. Okay, this is the side view. So this is your electric field. It is mentioned 25 Newton per Coulomb. Yes, and normal to the, it is given normal to the surface means area vector makes an angle 60 degree with the direction of electric field. This is the area vector, A vector. It makes an angle 60 degree with the direction of electric field. So this is your 60 degree. Angle theta is 60 degree. Clear? So phi is equals to, answer will be phi is equal to EA cos 60 or EA cos theta. EA cos theta. So what is area? Remember this thing. 25 Newton per Coulomb. Area value 10 into 15 centimeter square. So 10 into 15 and centimeter square you have to convert into SI unit, that is 10 to the minus 4 meter square, and this will be cos 60. Yes, so it will be 25 into 150 into 10 to the power minus 4 cos 60 value 1 by 2. Final answer will be 0.1875 and electric flux unit is Newton meter square per Coulomb. This is the answer. So this is your final answer. Yes, I hope this is clear to all of you. Okay, next come to our upcoming question. Yes, the question is C. What is the question? So a cube is given in question. This is one cube is given. One cube is mentioned clearly, and you can think this is your x direction and this one is y direction. Yes, y, and this one is x, and it is mentioned electric field is along this direction. E vector is equals to E naught I cap. E naught I cap, and each side of cube is A. The value is A. Clear? Yes. Each side value is A. It is given in question. Bas. So question is find electric flux through a cubical surface as shown. So question is find electric flux through a cubical surface. Through cubical surface as shown. Find electric flux through cubical surface as shown. Clear? How many surfaces are there? 6 surface. In case of a cube, 6 faces are there. If electric field is acting along positive x direction only, so out of 6 faces, only through 2 faces electric field lines will cross. What are those faces? Now see this figure properly. So out of all the faces, if I will draw this diagram again like this, as electric field is acting along positive x direction, so through this surface, out of 6 faces, through this face and second one is this face. Yes, electric field lines will cross, and through rest of the faces are placed horizontally with respect to electric field lines. और electric field lines कौन होला? Electric field lines गुड़ाक या तो इधर tangential सब पड़ेगा. So when electric field lines are tangential to the surface, so flux will be 0. So out of 6 faces, only across two faces you may calculate the flux value, and in remaining 4 faces the flux value will be 0. Yes, so we can say, so flux phi total is equals to phi 1 plus phi 2 plus phi 3 phi 4 phi 5 plus phi 6. Let flux through this surface is phi 1 and flux through this surface is phi 2, and phi 3 value 0, 5 4 value also 0, 5 5 0, 5 6 also 0. So what is the value of phi? Phi is equal to EA cos theta. Yes. So in case of first surface, the area vector value, it is a part of closed surface, so area vector will be outward sense. This is your area vector A vector, and electric field vector in positive x direction, electric field vector. In second phase, if you will consider the second phase, this is the direction of area vector, and also for second phase the electric field is along the direction of area vector. So for first phi 1, the value will be E into A into cos theta. Cos theta is cos 180 degree, and plus phi 2 value E A cos 0 degree. Cos 180 minus 1, so it will be minus E into area value is A square plus E into area value is A square. So the final result will be 0. Clear? So remember, if an observer is observing this thing from this side, so you can say for first surface flux is entering, and for second case flux is exiting. So flux entering is positive, flux entering, another one is flux exiting. Yes, you may think in that process also, but in mathematical process that is very easy. EA cos theta. Yes, I hope this question is clear to all of you. Okay. So one thing you may remember, if any closed body placed inside uniform electric field, net flux is 0. So in note point you may mention this thing. In note point you may mention, if any closed body placed inside uniform electric field is placed inside uniform electric field, then net flux is 0. Then net flux is 0. Net flux is 0. Yes, this is the note point actually. So keep this point in mind. Okay. So this is all about for today's lecture. So wait up to our lecture number 16. In that lecture we will discuss the Gauss theorem in detail, and again we will solve many more numericals based upon your electric flux and Gauss theorem. Yes, after that we will discuss applications of Gauss law. So wait up to that moment. So kindly like, share and subscribe to my channel. Thank you. Have a nice day.